Hello again. We're doing something very special today. It's square roots. It's a specific type of number, and it is a number. And that's what students get very confused about. They look at this and they think it's like some kind of weird operation. It's not really. It's a number, but it's written unusually. And there are a few things that I have to explain beforehand. Now, some of you who have had exposure to square roots before say, oh, a square root looks like that. That's not actually true. This is not a square root. It's a radical 4 or a root 4. But students say, well, no, my teacher calls it a square root. Yeah, it is a square root, but there's a reason why it's a square root. Whether or not you believe it, there's a hidden 2 up here. Now, you will never see the 2 in any book or any calculator or any subscript. It's automatically assumed to be there. The only reason why I mention that is because later on, you'll be doing problems that look like this. It'll say, instead of root 4, it'll say cube root 4. And that's a 3 instead of a 2. And that makes a big difference. But we're not going to get into that just yet. We're going to work just on square roots. But for something for you to know later on so you can at least apply it. There's actually an imaginary 2 there. Hence square and then root. But that's not terribly important. What's terribly important now is just solving the type of problem. And with that said, basically what this problem reads, what it tells you to do is, okay, this is a number. Well, okay. It's a number times itself exactly that equals 4. Is there a number times itself that equals 4? And the answer is 2. 2 times 2 is 4. And that's the only number that will work. 1 times 1 will not be 4. 3 times 3 will not be 4. Only 2 times 2 is 4. And some students say, oh, I already know the answer is 2. Let me show you a different way to do it, though, because when you end up doing more difficult problems, you won't be able to just solve it really quickly. For instance, I'm going to tell you something. What's the square root of 625? If you know it, congratulations. If you don't, then you don't. The square root of 625 is 25, because 25 times 25 is 625. But not everybody knows that. That's the whole point. I mean, you can practice your math over and over and over again and you'll figure that out. But if you wanted to figure it out, you would just kind of do it the way that I'm going to show you right now. Like I said, though, if you already know this off the top of your head, no point doing it. But here's what I do when I do square roots. I create something called factor trees. And you might have seen this, if you're a high school student, you might have seen this in elementary school. Basically what you do is you factor the number into what it can be divided by. So what number times what number is 4? And that answer is 2 and 2. 2 times 2 is 4. Can you split 2 any more than that? And by the way, 1 and 2 doesn't count. You can't use the number 1. Can you split 2 anymore? And the answer is no. Well, here's the interesting thing about a square root. And this is why I put that number 2 here. What it's asking for is take out 2 of every number that you see. Take out a pair of every number that you see. That's pretty much it. So, do I have a pair of the exact same numbers here? And when I do more difficult examples, it'll make more sense. But if you already know what the square root of 4 is, then you can just ignore my little rant or tangent. So you have to take out 2 of every number that you see. Well, I see 2 2's. You take them out, you take the pair out, and you represent it as just one number. So I take out 2, my answer is 2. Same thing here. Square root of 9 means, well, what number times itself equals 9? And the answer is 3. But let's say you just didn't know that. What you would do is you use factor trees. 3 times 3. You can't split 3 anymore. These are called primes because they can't be split. This number, by the way, is called the composite number because it can be split. Any number that can be split is composite. Any number that can't be split is called prime. Back to what I was going to say, though. You circle your primes, and you're taking out pairs. Every pair that you take out goes out as just the number itself. So I take out a pair, and my answer is 3. With 64, and this is where the example is brilliant, because now it will make sense. I want you to factor it till you get only prime numbers. Let's just say you didn't know that the square root of 64 was 8, because 8 times 8 is 64 perfectly. Let's say you didn't know. Let's say you said, okay, and this is sometimes what my students do because their multiplication skills aren't as great as they can be, but that's fine. They still make the effort, they still try, and they still want to get the problem right. Because why would you want to get a problem wrong when you can get it correct? So they split 64 into 32 and 2. Now, like I said, you circle your primes. You can't split 2, you're done. Split 32. Now, some people say, oh, I think that's 8 and 4. It is 8 and 4. You can split 4, so split it. Circle your primes. Don't circle a 4, because that can be split. Only circle the numbers that can't be split. So you circle that. Now we're going to split 8. 4 times 4 is not 8. 4 times 4 is 16, because a lot of students put down 4 times 4. No, it's not. 4 times 2 is 8. Circle your prime, and keep splitting everything you can. Now, like I said, some students say, oh, this method is so long and boring. When you get to the cube root of numbers, and the 4th root, and the 5th root of numbers, this way is actually very helpful. And I'm talking about pre-calculus students, calculus students, college algebra students, who really like this method. And because they can't figure out that the cube root of 243 is, well, maybe that's, I'm sorry, the 5th root of 243 is 3. 3, 9, 27, yeah. Anyways, I digress from that. So what you do now is this. It's the square root, so you have to take out every pair that you see and represent it as one number. So here we go. That's a pair. You're only taking them out as pairs, so it's a 2. That's another pair. Take it out as another 2. That's another pair. Take it out as another 2. Anything left over would stay inside. Is there any other prime number left inside, though? And the answer is no. 2 times 2 times 2 is 8. But if you already knew the square root of 64, you already knew that. Yes, it helps if your multiplication skills are up to par, but not everybody's is. And sometimes you got to use this method. And like I said, it's better to get a problem correct than not correct. Okay. I've got 3 more problems, and you already know what the square root of 9 is. So we're going to assume that everybody knows the answer is 3, which is fine, because I already wrote it here. So this answer is 3. No, it's not. The square root of 9 is 3, but then there's a negative out in front. So the answer is negative 3. The square root of 9 is 3, but there's a positive negative out in front. So it's plus 3 or negative 3. Sometimes your teacher will just write plus or minus 3. It's the same thing. You can write plus 3 or negative 3, or you can write plus or minus 3. Either answer is sufficient. I just wrote this out so it actually makes sense. Because I know students, when they see this, they don't actually know what it means. But if you write it out like this, oh, okay, that's what it means. And the last one, square root of negative 9. What's 3? No, it's not. 3 times 3 is 9. It's not negative 9. Oh, then it's negative 3. Negative times a negative is a positive. It's not negative 9. You can actually do this problem. And I'll give you a treat. I'll show you how to do it. But this is generally not a problem that you see. This is generally not an answer you're given right away. It's an answer that you're given when you experience square roots enough and your teacher thinks that you've experienced enough math. But it's usually not given right away. What your teacher will say is this. No real solution. And as long as your teacher wants you to put that down, that's fine. But later on, your teacher is going to tell you to do it a different way. And I'll show you how to do it so it makes sense. And I'll show you using my method right here. So you have the square root of negative 9. You can actually do this. What you do is this. You split it into negative 1 and 9. You split the 9 into 3 and 3. Now, like I said, every pair goes out. So the answer is 3. You're like, well, no, the answer is not 3. I agree, it's not 3. Whenever you have a negative 1 that you factored out inside a square root, that negative 1 is called something, excuse me, I said that wrong, is something called I. And I stands for imaginary, or imaginary number. Now, you might be saying, oh, what is this? Well, when you're using vector addition, vector subtraction, concepts in calculus, when you're graphing on the imaginary plane, that's when you really get into imaginary numbers. Are you really going to see that in this point in your life of math? The answer is probably not. It depends how ambitious your teacher would be. But even I, if I was teaching a regulated course, would probably not start graphing, and start showing all this stuff, because it would just start confusing everybody. And what you have to do as a teacher is, keep everybody on track, do what they're supposed to do, and ultimately learn what they were supposed to learn at that particular time. So, it's a drawback, but it's a price you have to pay too. So you pull out the -1, and that automatically becomes an I, and your answer is 3I. But like I said, if you're just starting square roots, your teacher probably wants you to put no real solution. I suppose it would impress them though if you put 3I here. It's pretty cool. Like the square root of -16 would just be 4I. Square root of -64 would be 8I, and so on and so forth. This is part 1 of square roots. We're going to do one more aspect of it. Pretty cool, but this second part won't take that long. So I'll see you in a few minutes. But other than that, have a great day for now.